Holy cow, I haven't seen that. It's an RFA hip. Now that bot's kind of weird because, if you're looking really closely, you'll see very close together in the pelvis are two vertical actuators, which is the rotation. And then right underneath the rotation, you can see where the flexion kind of comes out horizontally. And then finally, there's the abduction. That's to say, that's an order of operation I'd never seen before. And I'm glad to see someone did it. And maybe they tested it out and found out, yeah, it doesn't work as well in the ring as we thought. Okay, but if you have a robot that's a bit stiff and isn't able to do that, it might really limit what you can do in your research. But at the same time, the reason why everyone is doing all these athletic things with the Unitree is because that's the only thing you could do with it. You can't really do anything that's dexterity because it doesn't have the hands for it. And that's the name of the game. So the researchers just say, yeah, I want to have an Optimus, or I want to have a figure, or I want to have an Aptronic Apollo. It's because they actually have like working hands that I can go ahead and I can start doing stuff. Every bot is kung fu fighting. Those bots are fast as lightning. In fact, it's a little bit frightening how they fight with expert timing. Now, I'm not going to sing because I'm really bad at that. No one is doing the right thing, rushing straight into the fight ring. Um, ain't one building us a damn thing, only dazzling us with fight bling. So that's kind of my lament. The reason I bring that up is I now want to show why that's a concern. And one of the things that has to be taken care of when thinking about these mechanisms, there is nothing keeping it from moving around. There's nothing to say it has to be in that position. I can move it to any position. And then, of course, I can continue to move this around however I wish, and it will still work. And you'll see this one is kind of in, I guess you would say, its perfect position, and this one is not. So, what is keeping this from moving around? What keeps it from being able to rotate in that direction? We can twist it that way. And so you see there's lots of places for that to kind of rub up against something and cause some kind of difficulty. One thing to consider. Now, there is another way of doing it, and Atlas, or I should say, Apollo, and I think also the bot from, and I think maybe even Nura has done that as well. Is they decided not to use a spherical Heim joint, and they used a series of pin joints that they kind of lined up to be able to restrict that, to kind of prevent that movement around there. And it also had the other advantage that the way they did it is it gave it slightly more motion in kind of this what you call this direction, because they were doing it pretty much on the well, they do it on the ankle also, but on the wrist, it allowed them to have more range of motion on the wrist because you didn't have this problem here of it kind of bumping up on the edge of the wall of the sphere. Okay, so good morning, Marwa. Is there any interesting robotics news over the past
Oh my
couple
god.
days that
I
anyone
think
was talking about?
it's a lot of news. You are an ex, you can catch up. A lot of news. So I'm so excited
Yeah.
about all happening. I know we have a lot to say today. Yeah.
Yeah. I mean, obviously there was a lot of news coming out of South Korea with the Coral Conference that was, very interesting. But the one news item that seized it, and it's always like late on a Friday night. So my phone starts blowing up in the strangest hours of the morning. To see like, did you see this? Did you see this? And a lot of the commenting is on the Optimus being allegedly trained kung fu. Okay. And people taking breakdowns and stuff like that. So that kind of seized it because of, in a sense, it's a response to what we've been seeing Unitree doing for months now, and that is showing the dexterity. I shouldn't say the dexterity. It's more like the ability of their bots to do a lot of kung fu related moves, which is whole body motion, stuff like that, being able to do kicks and flips and spins around, stuff like that. And so this is sort of an Optimus update that we could do a little bit of a breakdown on to understand what it is and what it is not. There, I guess you could say, a lot of people are reading between the lines and and really inferring things that just is not there. So that's what we want to do. So I don't know if you've got that queued up. It was uh, like a minute and a half video showing Optimus kind of going through what I think is probably more accurately described as kind of a set of martial arts moves.
Okay.
And
Do
the
you want
reason
me
I
to
say
show the
that
video?
is yeah, go ahead. Let's go ahead and bring it up and take a look so the audience can see it. They've probably already seen it a dozen times. And we can see there is a human, obviously, that's a sparring partner with Optimus. And they're going through a series of moves here. And the big question everyone had is like, is this teleoperated? And the answer that came back was, no, it's not teleoperated, it's AI. That's the official response. From that, a lot of people inferred way more into what's going on in it. So the first thing is like, this is not the first time we've seen Optimus do moves like this. Um, maybe it wasn't martial arts, but it was dancing. And these were dance moves that were sort of learned by doing some motion capture. And, the motion capture was then put into RL and then did a lot of practice on that. And then the robot was able to actually duplicate or replicate, I guess you'd say, those dance moves fairly faithfully and showing that, oh, definitely a lot of movement. And now this more than likely is not telerobotic control, just because it's a lot harder to do telerobotics and full body control than it seems. People are starting to get to that to be able to do it, but it actually would be a lot easier to just let the robot go through that and figure these things out than to have a teleoperator that's off on the side trying to do these things. So it's much harder than it would seem to do that because you have to get, like I say, the full body control, which means you have to track everything that's going on. Um, Now that said, it does not mean there couldn't be a certain amount of human input on what Optimus is doing. Because we already see this kind of with Unitree, is that the Unitree bot comes with a controller that you can use it to, with a joystick, to tell it to go front and turn left and turn right and everything else. And also a bunch of buttons you can push that has some pre-programmed sequences in there. That'd be like, wave high or give a hug or do something like that. So it's quite possible you could have someone doing that kind of, just pulling up, we want you to do this at this point. That so I'm not actually having to go through it. More than likely, I don't think that was the case, even though it could be. So before anyone says, yeah, but what about the guy in the back that's got that what looks like a hand controller in his hand there, that with the gray shirt? What he's doing is he's controlling that overhead crane. So you can see for safety measures, there's actually a lanyard keeping Optimus up in case he falls down or whatever. And that crane has to kind of be always on top of Optimus. So when Optimus starts stepping forward, that crane has to move. The other thing is that he more than likely has like a safety switch in there, some button just in case something goes awry, that just be able to go ahead and stop that. So I don't think there's any control going on there. What a lot of people had said is like there's remarkable synchronization between the human and the bot. It's just remarkable how Optimus is able to follow what the human is doing. I mean, that's the comments that I'm seeing everywhere. And it's like, you get it backwards. What it is the human is following Optimus. That's how you do the ballet, is that it's very easy for a human to track someone else. Now, this is not perfect mirroring, as you'll notice. A lot of it is very similar. Okay, so first thing, I know absolutely nothing about martial arts. I've never taken martial arts training or stuff like that. However, I have had a chance to speak with a couple of people who know a thing or two about martial arts. And one of the things they kind of point out is it's very common to do something called, I think, a kata, where you go through a series of kind of rehearsed moves as almost like a warm-up exercise. So it's very common in the dojo. Everyone just go in there, you just go ahead and do that. And it gets to the point that it's just completely memorized what you're supposed to do. You can close your eyes and practically do everything. Typical kind of warm-up routines. And we see this in, Tai Chi, Pilates, stuff like that. Everyone just kind of knows what's going on. The other thing is that this is not kung fu. Okay. The martial art, if this is a martial art here, is more of a Japanese style than a Chinese style. And there's also some other moves in there that have been pointed out look like they come more from like Mortal Kombat, which is a video game, or from Rocky with the boxing gloves. So it's, if anything, it's more MMA style than it is Kung Fu. All right. So that's the thing. And that's coming from someone, I'm not a Kung Fu master. I wouldn't have known that because someone said, oh, look, he's doing Kung Fu. I would say, oh, okay, I guess he is. But it turns out if you actually talk to someone who has studied Kung Fu, to say, well, it's not. All right.
So why
So
the next? I think I saw Elon Musk was just retweeting. I learned kung fu from Keanu Reeves.
yeah,
That
yeah,
keeps moving.
because maybe he doesn't know the difference between, kung fu and jujitsu and karate either. So, and then neither does his team. It's like they don't know it. And I guess this kind of thing is like, if you know, then you would know this is not. So, I'm relying on people who are actual experts because I wouldn't be any wiser otherwise. So, the main thing is we've all seen action movies all the time, and we've probably always seen, like, how this action movie was done, and there's a lot of stunt coordination. So, whenever there's this fight scene, they practice that fight scene. I mean, even on stage, I mean, you see these stage fights, stuff like that when you go to Broadway. Those things are really well scripted, and everyone knows what the thrust and parries are gonna be and how they're supposed to respond. That's why nobody gets hurt. So, everyone is looking at this and assuming this is, like, some real sparring that's going on here. It's like, no, it's not. It's like it's really well coordinated, and either, this is actually a stunt man, or maybe, it's a member of the Optimus team who also studied, a lot of martial arts in his youth and is coordinated at this. Um, you can see a lot of things if there's really not any contact. Now, Optimus is not pulling his punches, that because he may not even know how to do it. So, Optimus is like putting it up there, and again, it's the human is the one that's doing a really good job of tracking what Optimus is doing to make it appear that that was like what the intention was. So he gets up there and he's able to track Optimus's hand. He knows Optimus's hand's only going to go up there and is going to come to a stop, and it looks like there's a blow, or he's hitting it, or he's doing a reaction to it. Now, Optimus could pull the punch in the sense that if he came in contact when he wasn't expecting it, he would stop because that's what a cobot does. A cobot has an expectation I can move through space because I've moved through this space before, and I know exactly what my forces and torques are going to be that I should be experiencing through here. And if suddenly it goes off nominal, that means there's something wrong, and then it will stop and react. And in a sense, it would kind of come back. And that'll be kind of important because, um, unlike humans, Optimus does not need brass knuckles to go into a fight because he's already got them. And so I'm really surprised he's not wearing any sort of boxing gloves or something like that as a form of protection. I mean, overall, it's like you're inviting this um, interaction with the robot in a way. You'd think you'd take more safety measures than just hanging from a lanyard. It's like at least put some sort of protection on there. And so that's why it tells me it's like just heavily scripted, like any stunt coordinator would do. He may have actually a few things there to provide protection, but actually, I don't think so. I think he's wearing something else because it's been pointed out that the funny thing is like, man, why is he wearing Crocs? And I think the reason why he's wearing those Crocs is that the Crocs are already suited with some sort of motion tracking device. So there's a couple places, especially when he's over in the red carpet, you'll see it comes around. Well, you can see wires hanging out from the back of the human already. I think he's wearing some sort of trackers on his hands already because those gloves that he has might actually be. And you see the little red straps on his feet? Those are actually motion trackers. And every now and then you'll see a wire pop out in the front, like right there, boom, there, it just kind of snuck out for a second. Now, what's the purpose of that? It may be that it was they either did some pre-training ahead of time and that was the setup, or it may be when they're doing this interaction, they want to grab data from him on the interaction with Optimus. So it's not something nefarious to saying they're like, oh, they see, got them. It was Telerobot. It's like, because it doesn't make any sense. Optimus is not faithfully mirroring what he is doing. Maybe it could be used as a cue to Optimus of what you need to do. So when you're taking any sort of martial arts, or I guess, any sort of sport, there's always how do you counter what your opponent is doing? What's the appropriate move at this point? So if he's throwing a left hook at me, what should I do? Well, I need to duck, or I can put up my gloves or something like that, try to block it. Which one? So sometimes you need to know what should your counter move be in a particular case. And a lot of it will just come down to understanding what that person is doing, what your opponent is doing. One way, we'll use motion tracking, and from that, maybe something in the background says he's doing this, and then you go ahead and that's what your counter. The other could be whether Optimus is clever enough, and we don't know right now. It's like he does have cameras; he's able to observe the human. Can Optimus already recognize what the human is doing and react to that? And my suspicion is that maybe not yet, and that maybe they're doing that as a way of being able to. But that's assuming there is kind of Optimus is really choosing kind of what to do right now, the same way you would gamers. So anyone that's played, again, some of these like Mortal Kombat, or like Mario, where on your game controller you just push a button and it makes your guy jump, or lunge or duck or keep running or stop. It's like whoop, 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 and it plays through a certain sequence. So it could be that there are a lot of these smaller sequences, and at that point, you're deciding how to put them together to create the certain narrative you want that's going on here in this particular scene. No different than an LLM, right? LLM is a bunch of tokens. You put the tokens together and you create a sentence. So now what you're doing is you have a series of predefined, almost like muscle memory of what's going on, and potentially you could call that up at any point to react to something like that. I just don't think they're at that level yet. Now, a lot of people think they are, but I really think this is a whole stage script that was taught, and in a sense is AI because it was washed through RL at the motion cap data, put it in there, able to train the bot, and then it's able to play the sequence. And like all of them, like Unitree, which is doing the same thing, it's also able to react to perturbations. So it tries to do something that suddenly you kick it. It's like, whoa, wait a minute, I've got to balance myself and something like that. And so you can sort of see some of the cues here that at some point, the human decides it's time to shove Optimus. And that happens as soon as Optimus comes and like locks his hands like this. Again, it's almost like in stagecraft. You kind of come up here and here's the cue. Now do it. So you see Optimus is ready because at that point, he knows Optimus is not swinging his hands and it's safe for him to come in. Now he comes in what I would say is dangerously close and even kind of puts his head in there a little bit in a position that he could be vulnerable to being hit. But he knows at that point that, Optimus is not going to do it because maybe that's the end of it. The only thing he has to worry about there when he does that shoving scene is physics and there's inertia and everything else is going. So when Optimus is shoved back, suddenly his arm kind of goes up. And that could be partly, the physics, the fact that suddenly his torso bends and his arm is not moving at all. So it's going to go a little bit higher. And then the other is that um, Optimus' prime directive at this point is to not fall over, is do whatever to maintain your balance. And you and I know that if someone pushes us, we start falling. The first thing is our hands are flailing, whatever. It's like cats spin their tails. We will do this with our arms. And if there's someone or something nearby, we might casually or accidentally hit them with that. So you have to be extremely um, careful and comfortable that that is not about to happen. And now, again, this is not like some average Joe. I think he's probably got cat-like reflexes. So he was able to notice that he would probably be able to, pretty quickly protect himself and know exactly what to do. That's why you hire a stuntman to do something like this. And I sure hope they have good insurance because they're taking a certain amount of risk. And again, I'm just waiting for them to get a call from OSHA. That they're going to look at this. It's like, wait a minute. You get these. You're not even putting any sort of soft padding on the. I mean, come on. So you'll see that, it's maybe taking a little bit of risk, but, I guess
Just the
they're
hand,
comfortable enough.
the hand is quite different than what we saw before, and also the feet. This
No,
I'm I'm seeing
it's the same. Yeah, it's the same hand. So it's the Gen 2 hand. So, for everyone that's kind of wondering, it's like, "Oh, is this a Gen 3 bot?" It's like, "No, no, no. It's the Gen 2, not the 2.5, it's the 2." So it's the one that's been around for about 2 years now, and that's the 11th offhand that's on there, and you can also see, with the actuators that are in the wrist, so that's the old style. However, there are a couple Easter eggs in that we can see there's a bunch of Optimi kind of hanging in the background there. There's a mix of 2.5 and 2s there. So, when Optimus first starts to move, he reveals a bot that's hanging right now whose feet are not on the ground. You could just kind of went out of frame there, and that's an Optimus 2.5. Also, the bot that's near the operator with the gray T-shirt that's next to him, that bot's back is facing us, so it's harder to tell that it's a 2 point. So if you stop that frame right there, okay, when Optimus begins
this
to
one.
move, yeah, so let's just go a little bit more. As soon as Optimus steps out, because there's one all the way to the right, and that I believe is a 2.0, and Optimus is blocking the view right now of the 2.5 bot. And the way we can tell it's a 2.5, but yeah, you freeze it right there. It's just the neckline. Is you'll see that one has like the white torso, the upper part of the torso goes all the way around the neck. Whereas, as you can see, the Optimus right here, the whole neckline is black. So that's the first thing. Where the operator is, it's not so easy to tell because we're seeing the back of the bot. But if you look closely at the forearm, you'll see that the wrist actuators are kind of missing. So that looks like the forearm of the 2.5. And again, at some point, the forearm of the other 2.5 gets exposed. You can see, oh yeah, that's the 22 DOF hands that are on there. And there's finally a third one that's over next to the guy sitting on the desk. So when they start progressively moving all the way to the left there and get onto the red carpet, you'll see that there's an engineer sitting at the desk, and next to him is all right there. Boom. And you can see that's the 2.5 as well. Now, what's interesting is that we've never really seen these 2.5s in operation doing anything. Every time I've seen a video, I've seen them there, but always just hanging around doing nothing. The closest we've seen them is when they painted them gold and had them walking around in the office and at Benioff video, but without the hands at all. So we haven't really seen it do any operations. The closest we came is when they first fit one of those hands onto Optimus to catch the tennis ball, but that was the 2.5, or sorry, the 2.0 version with the hand to see if it worked. So we've been seeing these, but we haven't been seeing them do anything. And I kind of wonder, it's like, is that intentional that they're not revealing anything because they're getting ready to reveal this a little bit later? Because that's not the 3.0. That's absolutely not the 3.0. But that's there, and it's rather strange that they seem to be around but not doing anything. So they must be doing something with them. Uh, However, when it comes to a lot of motion capture and everything else, it's interesting that there's still a lot of reliance on the older 2.0 version. And that might be that they just have a plethora of them, that, they've built way more of them than they did of the others. And, and the other thing is maybe they don't mind using them in a situation like this because it falls down and breaks. It's like, oh, it's okay. It's not the new version. Doesn't have the expensive hands on it or anything like that.
The but
Um,
the feet
Now,
seems
yeah.
something new in the
Mhm.
feet. Do you see something in the feet different or the same?
See, basically, no, the cover is missing. So the upper part of the foot is, that's why it looks different. Is that when it's really hard to tell here. You have to go to like a full screen mode and then try to look down there, and all you're seeing is the covers are off. And I don't know why that it would have taken the covers off, what the reason for that would have been. So I think that's what exposed it. If they put something different on the foot, like if they attached a different sole there, maybe it was just to prevent slipping, or maybe to have it slip more. I mean, it could be two reasons, because you notice when there's that kick is happening, it's rather interesting in that kick sequence. When the kick is happening, the plant foot tends to slide around a little bit. And I and also the ankle does like some weird things. He twists his ankle like right there. You can almost see how the ankle's at a weird angle. So in those sequences, when you look at it, that plant foot is wobbling around quite a bit and not staying on there. And I almost wonder if it's just not responding fast enough, because it ends up on the edge of the foot every time and then sliding and then falling down flat and coming over again. So it's doing a little bit of that. So you would think it would just slide, but instead it rolls on the foot and then kind of slides over and then tries to level again. Now, the other thing about the kick maneuver that it does, it's kind of interesting that it may not be able to do a faithful, I don't know if it would be a karate kick or whatever style kick that is. Again, going back to the Optimus will suck at soccer, because the order of operations, flexion comes last. And so it may not be able to kind of perform the kick with the angle that the knee would have to be there. So some people looked at it and said, yeah, it's like, it's not quite the kick that we would expect, because of the difficulty of maybe opening up the hip without the fact that I think it's ARF. So yeah, the rotation is second, when it would be better if it was maybe like it third. But yeah, that's what. Now the other thing is like, if you're going to have a fighting robot, there's probably going to be some design decisions that you make. If you really want it for fighting in the ring. And it was interesting yesterday. I, s- I, I saw a post, and it was for a robot from Rec, and I looked at the hip design. It's like, holy cow! I haven't seen that. It's an RFA hip. And that was like, yeah. I was like, wait a minute, what's that about? And someone from Boston Dynamics, who's like the product director, is like, wait a minute, you think there's any advantage for this for boxing? And it turns out Actually, the CPO of Rick said, "No, it's terrible for it because evidently it can't strafe." You know, I'm like, "Strafe, what is that?" And evidently, it's just like being able to like kind of go sideways. Which I was looking at, I thought, well, maybe it is. So maybe they've already tested out and realized it's wrong. But it could be that if you're thinking of having a box, a boxing bot, what's the most important thing in boxing? And a lot of it is going to be bobbing and weaving. So how can be so much running? So if if the far hip is best for running, it may not be the best in the boxing ring unless your whole idea in the boxing ring is just keep on running circles around there. But if the idea is like there's engagement, and maybe there's a completely different reason you want to do it. And I'm not saying that I know exactly what the best. Yeah. Now that bot's kind of weird because if you're looking really closely, you'll see very close together in the pelvis are two vertical actuators, which is the rotation. And then right underneath the rotation, you can see where the flexion kind of comes out horizontally. And then finally, there's the abduction. That's to say, that's an order of operation I'd never seen before. And I'm glad to see someone did it. And maybe they tested it out and found out, yeah, it doesn't work as well in the ring as we thought. But they would know better. So what that means is if you're designing a bot for the ring, you're going to design it very differently than it's supposed to be on the shop floor. Uh, and now Optimus was never designed for kung fu or backflips or anything like that. And so it's going to have difficulty competing with Unitree on that front. It's going to be very, very difficult. It'll be interesting to see when they go in the ring how it comes out there because it may not be so much being able to do these weird backflips. It's going to, in the end, be about being able to take a blow. And that means really testing the robustness of everything right down to your actuators. How much they can take the blows and not get damaged because harmonic drives can be very sensitive to shock and vibration. Um, and so, that would be rather interesting and obviously just repeated being hit. Now, we've seen Unitree take a lot of punishment. They keep on showing these videos that are just like, oh my goodness, the poor little guy. And he's like popping up like almost instantly after getting knocked over and getting hit very, very, very hard. So, these robotic leagues that are being set up, that might be part of the purpose. I mean, obviously, there's a lot of entertainment value in there. Seems to be quite a lot of interest, a lot of leagues coming up. Everyone is sort of saying, "Yeah, we're ready to go in the ring. We want to do it." Maybe we will see Optimus appear there. I don't know if there's going to have to be a weight class because maybe Optimus has a huge advantage over Unitree right now because it's a 2-to-1 weight advantage at this point. That could be rather interesting to see. Um, but what's the utility? Can you think of any utility of putting the bots in the ring besides entertainment? And almost like a type of oil lust or whatever you want to call it, bloodlust, that a lot of people just want to see these robots get destroyed.
I think the most the next I think the conversation about Unitree versus the US, I think Humanoid, I think that's something I saw very often about the competition and how things will evolve. So
Mhm.
I'm not sure by seeing this video. I saw some of the researchers say like if we can't buy these robots, I think we will purchase Optimist versus Unitree. So I'm not sure, to be
Yes,
honest, if
yes,
it's
yes,
really
yes.
y can you use it in the lab? Yeah, Unit 3 seems to be as we discussed before recording, it seemed impressive. They dominate, I think, the scene now for most of the, I think, purchased by
Mhm.
research labs and other companies that using them for testing their, yeah, the brain, whatever they try to do now. But yeah,
Yes, yes, and absolutely. I mean, that was a genius move on the part of Unitree that they were able to get an affordable robot that they're willing to sell, and it's open enough that everyone can get in and start doing stuff with it. So they're doing, very impressive things. All the RL researchers are doing it, and the funny thing is, there are companies that humanoid startups that actually are buying the Unitrees because that's the quickest way they can get their RL team online to, to get those guys out there and starting to test all their algorithms out and what they want to do while they're building. And of course, they're using to do teardowns to see, what's working, what doesn't work, a lot of that. So it is in some ways actually helping the competition to Unitree to be able to come up with something. Um, it with Optimus, it'll probably be way more expensive and it's completely different architecture. They're not using anything from NVIDIA. So it might be really hard to figure out. It's like, well, how do we, you know, is there going to be some sort of open API that we able to get in there to be able to do some work with Optimus? The other thing is that there are a variety of different robots you could buy out there, and we can see that the Unitree is very nimble, and it's able to do a lot of things, partly because of its stature. It's like, I think it's under 5 feet tall or something like that, and it's might even be closer to 4 feet, and it's very light. It's half the weight of Optimus, and just from first principles standpoint, I mean, it's just a lot easier to do backflips. That's why all the gold medal gymnasts are so short because there's an actual advantage as far as inertia and being able to do backflips and balance control and everything else. So that is one kind of key difference that allows them to do a lot of really wild things. And so for researchers who want to push the envelope on those capabilities, they would love it. I mean, they want to have these bots literally like climbing the walls and being able to fall down and do all sorts of things. But if you have a robot that's a bit stiff and isn't able to do that, it might really limit what you can do in your research. But at the same time, the reason why everyone is doing all these athletic things with the Unitree is because that's the only thing you could do with it. You can't really do anything that's dexterity because it doesn't have the hands for it. And that's the name of the game. So the researchers just say, yeah, I want to have an Optimus, or I want to have a figure, or I want to have an Aptronic Apollo. It's because they actually have like working hands that I can go ahead and I can start doing stuff. And they're the right size also that to be able to do real kind of operations. So it may be that there are those that would like it for that reason. But just going back to the whole idea of there being a robot boxing league, um, do you see any utility or any positive outcomes to having something like that?
So it's fighting, you mean?
Yeah, I mean, just the fact that the bots are out there, battling it out, it's obviously entertaining. It's one way to make money. It's a form of useful work because people pay for it.
Yeah.
The I think, the potential outcome of it is the same thing that the F1 has, for automobiles. Everyone could say the Formula One is just pure entertainment. It's a complete waste. You're burning all this gas for I remember hearing those during the energy crisis back in the 70s. But the reality of the F1 is it's like it's an engineering challenge where they're creating an artificial set of goals that forces them to push hardware in a way that you wouldn't do in the normal setting. That's almost like the same argument for going to the moon, is that it pushed the boundaries in ways that we never would, and as a result, we got breakthroughs we didn't expect. And the same thing with the Formula One is like today's transmissions are way better because of Formula One, because they learn how to make transmissions that don't break under extreme stresses like that. Tires are probably a lot better. I mean, there's just like you can go on and on and on. I mean, some people it's like right down to like safety systems and stuff like that, and crash protection and all that stuff. So there's a lot of good things that kind of came out of that, and potentially the same thing would be here is that we need durability testing of the robots and, there's the kind of durability. Well, let's just run it in the factory and see if it falls down and breaks. And it's like, you got to push the envelope a little bit. And part of that might be is like, really having them battle it out. And then you start to see how good are your reducers? When do they start failing? When do you start overheating? What are the other things? And it could be the bots are being taught moves that may seem like of absolutely no value anywhere else, but may in the end because of this idea of cross training and cross fitness that um football players will take like Pilates classes and obviously weightlifting and stuff like that. It's like, what's it good to do to football? Shouldn't they just be practicing blocking and tackling? That's all they have to do, right? So just practice that. What's the idea of the Pilates classes? What's the idea of the strength training class? Why are they running? It's like, well, running helps endurance. Pilates helps, stretching and nimbleness and stuff like that. And every now and then you'll see like one of these guards do like some crazy thing in the middle of the game. And you're like, where did that come from? You know, and it could be that, he's catching a fumble or something like that. And it's just quite came down to it's like, had absolutely nothing to do with the fumble recovery drills, but that had to do with the Pilates class he took, or something else. So you could see the same thing that if there's never a situation where things go south, your robot will just keep on doing that. But we know things just happen. Things just
Yeah.
break, things just fall. And I want a robot that just has, like, this natural reflex of, like, just puts his hands out and catches the ball, comes on in. It's like, there's nothing there. It's like, where did that come from? And so these are the things that you hope the foundation models will have. So it's not too bad to have a certain amount of cross fitness. Uh, though I will admit, and I think I was on the record, I've got a post out there of what I
Mhm.
thought about this um, whole situation where, as everyone probably knows, there's a very famous disco tune from the 70s called,
Good.
Kung Fu Fighting. And so it's like, um, I basically just took those words and, satirized it a little bit and says, "Every bot is kung fu fighting. Those bots are fast as lightning. In fact, it's a little bit frightening how they fight with expert timing." Now, I'm not gonna sing because I'm really bad at that. No one is doing the right thing, rushing straight into the fight ring. Um, ain't one building us a damn thing. Only dazzling us with fight bling. So that's kind of my lament. It's like, it's all very interesting, but you're distracting us from the fact that no one has been able to show us the bots doing anything truly useful yet.
Hmm.
And why is that? And it's
Even figure
because you're behind
even
schedule. It's
figure
like, yeah, I mean, figure showing a little bit, but we haven't really seen it in the closest we've seen, I think, is coming out of China. Obviously agility has been showing that for a while, moving around. And there's, a couple examples coming from China that aren't like super exciting. They don't get a whole lot of headlines, but they're sort of showing that while Unitree is distracting everyone of going to the Fight Club, there's these others that, like, don't care about that, and there's, like, we've got a use case that we're going after, and we've designed our bot around, and that was the Walker, S2 bot, so that's the second version. The first one was like, okay, it's a bot, I wasn't really impressed with. The second one, it's still similar to the first one in some ways kinematically, but they made a couple little tweaks. It just looks overall more refined, looks a little bit nicer, and, um all the specs on it are like right where you need it to work in the factory. So it has your run of the mill 11 offhand. It has a wrist I don't like. It's the one I jokingly call the second elbow because it's so far up. It looks like a second elbow more than a wrist. But those wrists are easy to build. They're pretty strong, and it's adequate for the task that they have that they're looking at. So like the hand is like it gets the job done. Their legs surprisingly has the similar, it's not exactly the same as Optimus, but it's the same order of operation. It's an ARF hip. And so they're like a second generation ARF hip. And everyone that started out with an ARF hip in their first generation quickly went to FAR in the second generation because they realized there's a lot of problems. But for some reason, they saw that it worked fine for them, and they're able to walk 2 meters per second, which is well above the desired 1.2 meters per second. So it's like, okay, they've got a decent clip. They can work in the factory. Um, they've got enough agility in the hands. Their payload capability. It's a full size bot. It's not tiny. They did an interesting decision on the waist where they threw in a Y in the waist, which I was so a Y is basically what you would need for leaning forward. And in theory, you've already got that in your hips, so you don't really need it. So they didn't put the X in. I was expecting them, it's like everyone's putting the X in because they think you're gonna lean back and forth. It's like, you don't really have to lean. You can use your legs to lean as well. And agility does that all the time. Agility has absolutely no waist, yet it can move its torso just through what it does in its legs. So if you need a little bit, you can do that. If you need a lot, then you want to put something there. And it turns out they need a lot. And the reason they need a lot is they want to be able to do a deep squat to reach to pick up something off the floor. And so their bots design whereas I'm looking at the whole thing like, yeah, they kind of nailed it. It probably doesn't cost a whole lot, and they've got like big orders coming in already to deploy them in factories. So for me, that is what the goal should be. Is you're trying to do useful work in the factory, and I am sure Walker 2 will not be able to do any kind of kung fu. And maybe it wouldn't do really well in the ring. And they'll probably say, we don't care. We didn't design it for that reason. It might actually do all right. I mean, I don't think it's that bad. It's just like they're probably like, don't care. And I really wish everyone else would be focusing more on that rather than this. Now, yeah, having the fighting and stuff like that gets a lot of press and everyone gets kind of interested in it. But It really should come down to, so the safety. And what will be interesting is this a sign that Tesla is taking the bait? Because again, Unitree has controlled the narrative there, and as soon as you decide to do it, it's like, you're taking the bait on this one. And my recommendation is like, no, the goal is the brass ring you want to be going for is deployments in factories, doing useful work, and then your bot has value. Right now, the only value that the Unitree bot has is to researchers. To research what? There should be some end goal in research. It means, like, oh, we'll just do years and years of research, and eventually we'll crack this nut. It's like,
We see a
ah,
lot of video. It's very interesting, but you're right. What is the goal? You're doing all this great stuff, but what will it do? A useful work or just? Do you think it's just? I don't know. Do you think? I think this form of criticism you now offering what we're seeing so far. What do you think is missing in that narrative? If we experience it's just sometimes you don't see yeah different voices like why you guys doing that?
yeah, and well, a lot of it is because you've got to have good hands, and you got to figure out how to control the hands in the training, and it's probably been a little bit harder for everyone to be able to do that, and but others are doing it because they're focusing on it. And again, if you get distracted, last year the Optimus team was a bit distracted, and part of it is like the We Robot event. Well, that was a great event. There was a lot of resources that were dedicated in that, and they may, like Formula One racing, they may have learned some things about it, about how to tune the teleoperation a little bit better, do everything else. It was an impressive PR event, but from the standpoint of development, it may have held them back. And again, you remember Bloomberg sort of asked Brett at one of these conferences a few months ago, it's like, why isn't your robot here? And it's just like, because demos like suck up so much resources and time, they're not worth it. And so you'd rather keep the bots and the engineers because it's not just like some guy's going to throw it in the car and like bring it over for an hour or something like that. It's like there's a whole team that has to go along there, everything else, and it just becomes this big distraction. So um, if your team is spending all the time doing demos, they're having really a hard time pushing it forward. Occasionally, a demo is good because it's like this exercise to go through to see what your bot can do. Sometimes it does push the limits, but if you're only doing it, it's just you cannot make progress. All you could do is just demonstrate what the current state of your thing is, and you can't push forward. So you have to be very careful in that. And again, a lot of it is sometimes literally hand waving or not hand waving because my bot doesn't have any hands. So, but I'll distract you with this other stuff of like, oh, look, we can do kung fu fighting. The reality is, if it was really doing kung fu fighting, there would have been some hand gestures in there. And it was like the whole time it was boxing. And the other thing you want to look again at the Rocky boxing, slow that thing down. And that normally in the Rocky thing is like, they hit with the gloves like that. And you'll notice that they never touch. So just like good stunts, is they never you think that they hit, but they actually came close, but they never actually hit. I think the closest was
Ah,
like there might have been
interesting.
like a little bump that way, but there was never actually any contact. And again, with a lot of the hand blows like that, optimists are going up there. Ooh, oh wow, look, I just, you know, blocked him. It's like, no, you didn't. Your arms just happened to be coincidentally in almost the same location at the same time. How about that? So again, it just comes down to that it's about storytelling in narratives. And when we read books and stories, we're kind of told to kind of create the image, create the pictures. What is the author telling us? And we fill in all of the blanks that aren't there. And the same thing with movies is that we're so good at filling in the blanks. Uh, so we have kind of our own mid journey going on, right? That we see things and we don't think. So remember, people are horrible witnesses a lot of things because they don't really know what they saw. They think they saw that, but it's like, no, you didn't actually see that. And you find out later on that that's the case. Uh, Now, I think we've covered enough there. There's like one other topic that I'd like to quickly cover, unless you have anything else to think on this.
No, I think it's just about what's the topic we need to cover.
Oh, okay. Well, basically, it's an addendum to what we did last week. And let's see if I can go ahead and get this to kind of come on up here. And I'm looking for the window. Oh, I got lots of windows here. Too many windows here. That should go. I'm going to go ahead and share that. So, what I want to do is talk a little bit about this, and perhaps before I do that, I should share a different window. So we're going to talk about these kind of mechanisms again, which are these parallel kinematic mechanisms. They could be used not only in ankles but waists if you want, and of course also in the wrists. But before I do that, I'm going to stop sharing and share a different window to say why I wanted to bring this thing up because it's something I've been aware of, but I kind of glossed over. And I'm going to go ahead and bring this thing. I think I've got that up there. Do I have that up there? What I need to do is actually start a slideshow first from current. Well, and before I need to do that, and again, this is going to come down to how wonderful the setup slideshow. What I need to do is I need to put that in an individual window. And we're going to start here. And now I'm going to say from the current slide, and we're going to get that. Oh, not that small. Okay, right on there. And now, guess what? I think I find this window right here. Share that. Okay, so Limax put out a couple of really nice videos this past week, in which you can get really nice views of the Olibot in what they're doing, especially close-ups here. And what I want you to see in this waste mechanism, and you can see the linkage that comes on down here, this connecting rod. And I want you to kind of notice the angles that it's making here on that ball. And then I think we'll see a couple others there. So you see kind of the angle that's there.
Yes.
And okay, so the reason I bring that up is I now want to show why that's a concern. And one of the things that has to be taken care of when thinking about these mechanisms. Okay, so we talked about last week that you've got this ball screw drive, or sorry, not a ball screw. What you have is you have a spherical joint right here. So in order for this thing to move, we are attempting to move these two cranks. So when both these cranks move at the same time, they're able to change the angle of this. And because they're changing that angle, the whole mechanism is able to go forward. And that's very easy to kind of see from a side view. You look at that and it's a classic kind of triangular mechanism there. It's all very easy to solve. The problem is when you start to go out of plane, when you start to introduce like a rotation this way, you'll see suddenly those cranks are kind of forced to have to move in a different direction. And so they're not just moving along this pin direction here, they also have this other one. And the reason why a sphere is used there is because a spherical joint has 3 degrees of freedom versus a cylindrical joint, which just has one. So if we were using a cylindrical joint right there, you would see that would break. It would just, it would snap right off, or this would have to bend, or something's going to have to give. So you use that. And the thing is there's like a cylindrical joint and there's a spherical joint, and there isn't like one in between. Sometimes that's why you build these universal joints or Cardan joints, because they can kind of be a 2 degree of freedom joint as opposed to a three. And so a spherical joint is naturally 3 degrees of freedom, even though you only need two. In this case, we only need 2 degrees of freedom. So when it comes to solving the math, I'm kind of being a bit lazy here and just solving what needs to be solved and kind of ignoring the fact that there is another degree of freedom that we should be getting focused here about. And I'm just going to change this briefly to getting things a little bit bigger. Oh, I'm going to get rid of that thing there. Oh, get rid of that. So we can see things a little bit bigger here. So I'm going to interact now. And what I want you to see is that I can move that joint this way. There is nothing keeping it from moving around. There's nothing to say it has to be in that position. I can move it to any position. And then, of course, I can continue to move this around however I wish, and it will still work. And you'll see this one is kind of in, I guess you would say, its perfect position, and this one is not. So what is keeping this from moving around? What keeps it from being able to rotate in that direction?
The orange, I think, part.
Yeah, there's absolutely nothing keeping it from doing that. That's the problem. The only thing that would sort of keep it from doing that is friction. but you don't want a whole lot of friction there. So now these joints, as we've already seen, if we go really extreme and we kind of limit it, if we go more extreme here on this axis here, we begin to see this is bumping up against there because there's only so much limit of travel you have in that sphere because you have the cylinder that comes out that just gets in the way. So that's what kind of restricts my range of motion and why I would never want to exceed that range of motion. But then I have this other problem here that this guy can just move around like that. So the only thing that keeps him from moving around right there is rubbing and chafing. There is no nice thing that's keeping it from doing that. Now, they may be thinking, "Oh, we'll put some of the little rubber gaskets or something up there so it's not like a metal on metal kind of situation." But the thing is, you have to put some kind of stops on there, and those stops are just sources of friction. And so it's not just a problem there, it's also a problem here. So we can see these things move around also. So I've got the Optimus moving around, but there's absolutely nothing to keep Optimus from doing this. And actually, if anyone has a Tesla showroom near you and they have an Optimus model, go in there and look at both the foot and the wrist. And a lot of times you will notice rather than being aligned perfectly because it's a sloppy model, it's not the actual model, you'll see they're kind of cocked like that. They're not on there perfectly straight. They move around very easily because there's nothing to keep them from doing it. Same with this mechanism is, you're going to have the same kind of issue here as well. So we know this thing is able to go up and down. We're able to do it this way, but boy, we could twist it that way. And so you see there's lots of places for that to kind of rub up against something and cause some kind of difficulty. One thing to consider. Now, there is another way of doing it, and Atlas, or should I say, Apollo, and I think also the bot from, and I think maybe even Nura has done that as well. Is they decided not to use a spherical Heim joint, and they used a series of pin joints that they kind of lined up to be able to restrict that, to kind of prevent that movement around there. And it also had the other advantage that the way they did it is it gave it slightly more motion in kind of this, what you call this direction, because they were doing it pretty much on the, well, they do it on the ankle also, but on the wrist, it allowed them to have more range of motion on the wrist because you didn't have this problem here of it kind of bumping up on the edge of the wall of the sphere. So spherical joints have like one direction that they prefer. So rotating them about that direction is like really, really easy. I mean, the only thing that prevents the axis from being able to move continually around there is that this would like bump into the foot. But in theory, they could just spin, spin, spin. However, this way they kind of get in trouble going back and forth. So they're limited to like maybe plus or minus 15 or 20 degrees that way. Whereas in the other direction, you can get a lot more. You can like, maybe 45 or 90 or much more. So they have kind of a preferred direction than an off axis direction. And then they have this problem here of being a little bit sloppy. Well, as you can see, it could go all the way around to like impossible configurations, but hey, that's the advantage of being able to simulate. You can simulate crazy things.
It's really awesome.
So yeah, that's something I wanted to bring up that may not be aware, and hopefully I'll make a decent um,
It was
post
really,
about this.
yeah, I really appreciate this episode. It's really good episode, and yeah, I think it was really, really informative, and I appreciate to bring this up again. So yeah.
Mhm.
What else?
Yeah, so if anyone was like wondering what all that was about, there's a previous episode where
Yeah.
we did a deep dive on the what is the SPU versus the RSU types of ankles, which is spherical, prismatic, universal versus um, Revolute Revolute spherical universal, and we kind of explained the breakdown. But one of the things I kind of left out is it's there. It's one of the things like kind of the back of my mind, but it's like oh, and then when I saw Ollie and then just saw that twist, it's like yeah, it's a real world problem that you have to figure out how to do that, and could result in wear and tear in other issues you're not expecting. Just friction itself is always bad, right? That's loss right there. But too much friction can cause failures in some things, and I've sort of heard through the grapevine, stuff like that, a lot of these kidney waste, which is basically what Linux is on there, is that in some of the bots, it's turning out to be a failure point. It's like they're not as robust and as strong as everyone is thinking. And I think a lot of people realize that they may not have the stiffness. It's a parallel mechanism, and usually when you see like a parallel kinematic, everyone like just associates it with stiffness. It's just rigid and stuff like that, like a Stewart platform. That was the whole idea. It's like just rigid, and so it has that, but at the same time, it turns out to not be maybe as good as you want because you've got to get their distances right, so you have really good moment arms to be able to control it in different directions. And you have a bunch of Heim joints. I mean, you've got 3 Heim joints there, or sorry, 4 Heim joints, like, in there, and those can, boy, be a source of weakness and slop. It's so, um, and in many cases, it could be things like that are just kinda causing these linkages sometimes to deflect or bend or just cause that joint to, like, suddenly snap because it just doesn't like the fact that you're applying a weird moment arm on something, especially if that linkage is, like, not where it should be at the moment you're about to do something. So, yeah, word of caution to any designer out there is to really think it through and look at that, and then you may realize that the parallel kinematic, is not suited in certain locations depending on what you're doing, even though there's, like, huge advantages. So that's something I wish that paper would have addressed. I was like, "Well, wait a minute, how do you get rid of that 3rd degree of freedom there? That could be a potential source of problems."
Interesting. I think one of the comments for this episode, someone asked about the toes, about the humanoid feet. Why no one think about
Oh,
toes?
yeah, 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 why nobody has toes?
Do
Okay,
you think it's relevant?
it's okay. Alright, I'm not gonna dismiss that. I think there is some relevance to it, and it brings up a very good point because 25% of all the bones in your body are in your feet. So that already is like a hint. Wow, there was something important about our feet that nature decided to put 25 in there. The problem is we decided to then put our feet into shoes, and the effect of that is as if our feet are made of one bone. Depending on the shoes that you have. If you get Dutch wooden shoes, it's like, yeah, you've got no flexibility in there, all right? Most modern shoes at least have some flexibility around the toe box. So we kind of look at our feet as only having that, and we think of a toe box, not the toes. And this is why you're seeing, Tesla. I'm not sure if anyone else has it, but certainly Optimus came out with the with a toe box. Now it's not articulated. Sorry, it's articulated, it's not actuated, meaning they didn't put a motor in there. They basically have a little hinge there, and they have a big spring that kinda wants to keep it in the flat neutral position, and then when you push on it, it will deflect, and then when you push off, it'll go and it helps definitely in the stride. It helps a lot of ways because the one problem with having something which is flat is that, you know, uh, 2 things on a flat surface, as soon as I change the angle there, you see my contact goes from surface to edge to surface, and edges are really bad. It causes you to slip. So you'd want to have some sort of deflection on there or something like that, that at least keys some surface. So there's a lot of reason to wanna do that. Um, there's an argument about how important toes are to balance, and I think they're extremely important. The thing is it comes with a penalty, and the reason why those toe boxes are articulated, not actuated, is that, oh, then we'd have to put a motor in there, and then the motor needs a control system, the motor needs power, and the motor so it's like, we're not gonna do that, but what we're going to do is, in many cases, they do have some sensors down there that are trying to sense a little bit of where the foot pressure is, and then to let the ankles compensate for that. So, one of the kind of overlooked degrees of freedom in the ankle, and it's really tempting to get rid of, and that's the roll. So if you look at everyone's legs, there's 6 degrees of freedom, 3 up in the hip, and all 3 of those are really important. I mean, you can make an argument of which one's the most important, but at the end of the day, they're all so important, you can't really eliminate one. It's like, as tempting as it would be to say, "Oh, we don't really need the roll, do we?" It's like, well, I guess you don't need the roll if you only care about walking straight, you know? It's just really and it may also have other importance in maintaining balance and doing other things. So all of them in there, you can make a strong argument why you don't need it, and then you look at, like, the subtle effects and go, "Oh gosh, I didn't realize how important that was to keeping my bot from falling over." Or allow it to walk straight or go upstairs or something like that. And the same thing with the foot is that the foot, you want to maintain good contact with the floor. And if your ankle is not able to to turn, to roll this way, the more you spread your foot out. So think about that, if I gotta do a squat, or if I suddenly wanna spread my feet because 'cause I'm trying to get my balance. Well, as soon as you spread your feet, it's the actuator that's doing it. And your feet aren't spreading like this, your feet are being rotated like that. And the result is you suddenly go to a line of contact. So if you don't have this, it means it's like only one point where everything is kind of lined up on a flat surface where you have that good contact. And as soon as you go off, you start going to the line contact, which can be so it's got importance that way to maintain it. But the other thing it has is because it's actuated, you can actually push this way or push that way, which helps you get that balance. So when you start losing, you can kind of push off to get it in that way. Our toes do that. So, you get into this barefoot, get rid of your shoes. I've been walking barefoot, like, I'm always in my house. There's a lot of reasons. Ever since COVID, I I resist putting on a pair of shoes, and we have to attend a wedding this weekend. It's gonna be, like, the first time I'm trying to get my feet into, like, dress shoes, and it's gonna be torture. I might just buy some new ones. They're super wide because I know when I'm done, I was like, "Whoa," so, like, really, you don't want your feet being crammed in there because your toes have been forced to do something that is just absolutely unnatural. But now that you're barefoot and you're sitting there, you can kinda notice the importance of your foot when you sway back and forth. And as you try to change your balance, you'll notice that your toes are suddenly doing something. Like your big toe might suddenly be pushing down really hard to counter it all the way over to the other. So you start moving around, you begin to realize, wait a minute, it's not so much a toe box. It's just like different toes are getting in there because at some point my balance is so bad that I need that lever arm. And like my little toe is the one that's best positioned to really be able to fight that resistance. So you begin to notice it, man, it really plays a role. So it is a really good question of why not. And the short answer is that it's just too costly at this point for what the perceived benefits might be. And we think we can get away with a little bit with like the ankle roll that's kind of built in there and the toe box. The question is whether an actuated toe box makes more sense than just an articulated one, whether there's some shapes that you can put on there. And I think the interesting thing is there was a rather famous person, his name is Palmer Luckey, put out a post yesterday. I don't know if you saw that post where
Yeah, I
he
heard it
actually
was
asked
me.
us, how come no one is thinking about robotic feet? I'm like, yeah, haven't we been talking about this for about a year? So how come no one's paying any attention to that? And for those of you who don't know who Palmer Luckey is, anyone that's using like VR headsets, like, from Valve and basically the Vibe headset and everything basically came from that. He's the guy who invented that. And then after he went off and set up Androl and is working on drones and other stuff for military help. So he knows a thing or two about tech and deep tech. And 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 when he brings that question up, I think people might want to pay attention to that and say, okay, are there ways that we can do that? And how, yes, exactly, Yeah. So, I wish more people were working on foot haptics and V controls. The focus on the upper body digits is getting out of hand. So it's like, okay. Now, it's kind of good that he's thinking of the haptics because he was coming from that VR space and figuring out like how do you get a data glow and stuff like that. Because this is again the problem. How come everyone is doing boxing and no one is like showing us actually doing useful work? And it's because it's so hard to capture what's going on in the hands. And you need kind of haptics both ways. And so the more work that's done on that, and it's sort of the same thing again with feet, is that our feet have to sense what's going on the ground. And if we do that, we can do pretty well. And we've already seen that with a lot of these bots. It's everyone's RL bot. The first implementation is like without vision, and they're walking around blind, and they're staying up. And why is that? Is because their feet are feeling what's going on the ground and making decisions on how to react in that. So there's definitely a lot more going on in the foot. And the question is, how much do you make that passive, and how much do you make that active? So the articulated toe box with a spring in there is more or less making that a passive mechanism, which may be more than enough because you could probably design whatever compliance you want in there to be tuned to how you expect this to walk around. And then maybe you change it for certain situations. Maybe it's as simple as like turning a dial somewhere, or maybe there's some other way that you could automatically do that. Um, and then the other is whether it makes sense to make it active. But I think you can come up with a lot of passive mechanisms for doing that, taking more like these analog approaches, which in a sense is what our shoes kind of already help do for us anyway. Even though the big argument is, do the shoes help us or hurt us? Uh, as far as they modify the way we walk, and some people will argue, like the worst invention ever was a shoe. Because that's probably where like back problems and all these other problems have come from because um we should be taking a more natural approach to the way our feet work, but at the same time it's very clear well-designed shoe can give you way more performance. It's not just foot protection but also also performance.
No, I really enjoyed this episode. Always, it's really exciting. I feel this timing to be the amount of news and updates and everything. To be honest, it's just very exciting. A lot of things. I don't know what you think, Scott, about the coming stage, but it seems everything moving fast. I think that's really cool. Yeah.
Hmm. 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 Yeah. Absolutely. So yeah, we'll probably be seeing more exciting things in the coming weeks, I'm sure. um Shareholder meeting is coming up for Tesla. Big rumors about what they're going to show there. I'm not sure where it's sort of hard to tell. So, some people say someone claimed this or something like that, and I've never been able to trace it back authentically. Uh, Supposedly, maybe Elon has said that the Optimus bot will be at the shareholder meeting. I think may have seen something. I'm not sure if that's confirmed. That's why I wish to track these things down. It's not just like someone else's reading of something. It wouldn't be surprising that the Optimus 2 bot would be there, just like it was for the We Robot event. So I think there's expectation that they would at least be there to entertain the shareholders, maybe serve drinks like they did before, bags of popcorn, whatever. So I think that expectation would be there. A lot of people think just based on the invitation, the graphics and invitation, because there's always this um, type of criminology that goes on whenever there's like it's like what's going on. Let's say, what's the secret message is hitting, hitting all these things. Uh, is that an indication that they'll be releasing Figure 3, or not the version 3 at that, and the the question is it's a shareholder meeting. And obviously, the topic is gonna come up. They're gonna talk about some of the developments they've been doing, what the future is gonna be based on for Robotaxi and the Robova and stuff like that, and Optimus being 80% of the worth of, those things are all gonna be kinda talked about, and certainly there'll be videos showing that in the progress, and usually at the shareholder meetings out front, they'll park a Cybertruck and a semi and stuff like that, so the shareholders can kinda look at it, but it's not, like, really meant as a product unveil. Those are usually very, very special events. So I would be kind of shocked to see that that would be used, except maybe in the form of like a little tease of, where there is maybe a video or something like that, or showing some progress in some part of it, or just a weird unveil that it's, like, still kind of behind a curtain. You can see a little bit, the silhouette, just to say that, "Oh, yeah, we plan on it's gonna be released maybe in December and with production in there." So, I'm sure that the topic is gonna come up, but I'd be really surprised if it suddenly came out on stage and started dancing around or doing anything like that. I don't think, they would be there because, I'm looking at my watch or my calendar, it's like they got 4 weeks to go, and unless they already had something ready months ago, if they don't have anything built yet, then that's a tight schedule because you just don't wanna say that the night before we think it's ready. It's like, no, you wanna make sure this thing is rock solid and that you've been doing lots of testing and it's going on. That's not because, you know, the value of the shares will go up and down the next day depending upon how well something like that goes. So, yeah, there's a lot on the line. I think they would want to stage manage it a lot better. I just can't believe it's ready, especially with statements a couple of weeks ago that they're still struggling on parts of the design. It's like it's not design locked yet. So if it's not design locked, then you really don't have much to show. You don't have enough time to really train up your RL policies and everything else to guarantee that it's going to come out and do anything impressive. Except, okay, it walks across the stage and maybe that's about it. But I just don't think you could do anything epic. But, you know, I'd love to be surprised, as we all would.
Yeah, I think it was interesting. So, do you have any topics for the coming episode? I know
Boy,
you'll be traveling,
I
but,
never have any idea what my next topic is gonna be, and then suddenly just, it shows up, usually from events or something like that, or you see something. Again, it's just looking at Ollie from Limex and seeing that and because I had noticed that before, said, "Oh, yeah, it's time I kinda post about that and put that out there in the ether," and the fortunate thing is a lot of people actually appreciate these musings. They're a lot of them are just bookmarking it like crazy because they say, "Oh, this is something we have to consider. We have to something to consider." And so, I'm happy to see that it actually has some value to people who are building in this space.
no, I think a lot of
Mhm,
appreciation for all the
mm,
deep dives you do. I think that's,
mm,
very valuable, always. Okay, Scott,
mhm.
I'll end it here, and I wish you a
Okay,
good
you're
day.
welcome. Bye now.